Now we're live.
All right, guys, it's good to be with you today.
I can give her, yeah, I'll explain to her.
Can you also complain about the problems? Just kidding. No, that can be one of our jobs.
I can send her an email with the document too, because, we wrote it down anyway.
Well, I delegate Taylor.
Okay, so, yeah, I don't know. Let's just do this last one and do the other one and then call it good. So if R equals that.
So x squared, no, square root of x plus y. No, square root of x squared.
X
Yeah,
squared plus y squared equals that.
3 divided by 1 minus, what is cosine again?
Y cosine is x.
So 3 divided by 1 minus x.
No, because x is r cos. No, x is x equals r cosine of theta. So no, not quite. What'd she put for the answer?
Y over what the? So yeah, that's what you would do. You would replace cosine of theta with x. So it's just 1 minus x.
Sounds good to me.
X equals cosine of theta, right?
Yeah, that makes sense to me. So then how'd you go from there to there?
Then you'd square both sides.
So it'd be y squared, or no, x squared plus y squared equals 9.
Well, wait, would you need to square both sides?
I don't know.
Because, oh, humbug. I don't like this. I'm guessing you'd square both sides because in the answer you have a y squared.
Yeah, I would assume that too.
Oh, and then you have to factor out. So 1 minus
X squared. Too much factoring. Don't ask me to factor. Would it be what, 2xy or something like that?
Well, no, I'm not sure you'd have to factor that part out. I mean, I guess you could. But I don't, if we're,
I can't even think anymore.
I just want to go eat breakfast. Is really all I want to do right now.
How does this turn into 2?
I have no clue. I wish you'd put the answers in with work.
Trying to use Symbol Lab to make some sense of it.
So we've left pre-calculus.
I think we're into physics now.
Oh boy. Yeah, no. Nope. What does she even say? Why? Okay, no.
Okay, so we have. How do we have the 6 right there?
Oh, that was me. Because I was trying to square both sides, but I don't know. That's working out too well. Because if you have a 6 right there, you could multiply it. No. Because you can multiply it over here to get that and then put the x over here. But that's not going to work out.
There you go. Oh.
Oh my hell. So I mean, we're working with polar coordinates. And I completely understand how she did the example problem.
It's broken. Why is it just spinning? It's just spinning though. It's not tightening or anything.
Chris, are you just blankly staring at it too?
I'm trying to get with an online calculator to see if it might show me the steps or something. But Symbol Lab's not doing crap with it. I don't know. It's just so confusing.
Oh wait, we're on polar equations, right? That's what we're trying to do.
Yeah.
Well,
I don't know. I don't even get the example problem to begin with, so that's oh, yeah, I do. That makes sense. Squared.
well, I just looked in the book for polar equations, and all it does is plots the coordinates of polar equations. It doesn't like have us rewrite or anything, so I don't know. Maybe parametric equations?
I doubt it. And
Convert the polar equation r equals 4 cosine theta into a rectangular equation. Is that what we're doing?
yes, actually, yes.
Well, that is just a pop quiz, so it doesn't actually have any answers, so I have no idea. And it doesn't explain it in the book at all. Maybe if I go to the next page. So this says to convert r and theta to rectangular coordinates of x and y, we use x equals r cosine of theta and y equals r sine of theta. That says to convert xy to polar coordinates, which is r and theta, then we use r equals a square root of x squared plus y squared.
Yes. Yeah.
To find theta provided x does not equal 0, it just we need to use the circle for these in order to find them out?
You shouldn't have to.
Here's the book on it. So there's the equations they give us. So we use this to go to x and this to go to y, and this to go to theta and r.
That makes
Maybe
sense.
if we go to the next page, it might tell us. So do we have any 2 points?
Nope.
Okay. So that probably won't help us.
Graphing will either.
Sketch
Unfortunately.
the graph. What's this say? Graph simple equation. Well, all these ones use the circle, but it gives us 2 points to find.
Which is usually what they will give you. That's usually what it is.
That we don't have like any points.
This is just one of those problems that irritates me a lot. Like instead of using the quadratic formula, they're asking you to derive it.
Oh yeah.
Here, guys, let me screen share something that I have. This might help a little bit. All right, there we go. So they have a similar equation to us, but we just plug in separate numbers.
Say what?
Does that make sense? I mean, it doesn't have to
Uh,
make sense, but like it. I feel like this is more of a lead than anything else that we've seen.
to yield. We can multiply both sides of the equation by the denominator to yield.
So then on ours, it would be y times 1 minus cosine theta is equal to 3 instead of 2.
What? Wait. Hold it. Repeat that again.
So our equation is very similar. So their equation that they're doing is at the top in green.
Oh, yeah.
So ours is the exact same, just ours is a 3 instead of a 2. So we can basically follow everything that they do.
Oh, wow, you're right. Minus x equals to 3. Equals to 3. And then square both sides. And we get x squared plus y squared equals to x squared plus, well, for us it was 6x plus 4, I believe. Plus 6. Not mistaken. Subtract x squared from both, or subtract y squared from both sides, so she wants it. So,
Oh, I get it. Okay, hold up.
x squared equals 4x plus 4. 6x 6. And so then you want to solve for x. You want to solve for y. Oh,
What is the answer that we have?
the answer that she gave us is y squared divided by 6 equals minus 3 halves. Is that really the answer?
Minus 3 halves.
Oh, x equals. No wonder we were so freaking confused. No wonder. Okay, y squared equals. There we go. Okay, that all makes sense now.
I'm still getting there.
Yeah, take your time. Take your time.
Here's a. I don't know if this will help. If anybody's still stuck. Here's somebody who does a bunch of problems and converting them.
Well, I like this guy because it's like he explains it and it's like so similar to our equation.
So all they do is in this guy, all he does is anytime there's an r, he replaces with x squared plus y squared.
Yeah.
Yeah, that's what we're supposed to do.
Well, I did not know that. And then anywhere there's an x squared plus y squared, he replaces it with an r squared.
Yeah.
So what he does, if there's an x squared plus y squared, he changes it to an r squared. But if there's just an x, then it's r cosine theta. Or if there's just a y, then it's the other cosine theta one.
Yeah.
And then he combines like terms.
Where was I? Do you still need this up, Chris?
No, you're good.
Okay, I'm gonna stop screen sharing.
So if we look at our problems, anytime there's an x plus, so in the top one, if there's an x, then you change it with cosine theta.
Yep.
And anytime there's a y squared plus x squared, you change it to an r.
Yep.
So in the square root of x squared plus y squared, you could just change that to r minus r cosine theta.
For which one are you talking about?
Hang on, let me see real quick. So for the equation that's the square root of x squared plus y squared minus x equals 3,
Yeah.
we could substitute where it says the square root of x squared plus y squared. We could substitute r squared into that. Take the square root, so then it would just be r minus r cosine theta.
Okay. R minus r cosine theta.
Yeah. And then that would get rid of all your x's, and that equals 3.
Here. Cosine. Oh, theta. That actually makes a lot more sense.
And so that converted that one over, and then you have to get rid of all your r's, I believe. Oh, he doesn't get rid of r's, he just factors it out. So r minus r cosine theta equals 3. So that one's solved. Is that the right answer?
Nope, this is the right answer. The one at the bottom.
For that problem, that was the right one?
Yep. Yep.
Really? That doesn't make sense. No, because I did what? I did an equation that's not even existing.
Well,
Because
I gotta.
if you look at the original equation, it's just x squared plus y squared equals 9, right?
The second one?
Yeah.
Yeah.
So all you do is swap out r and take the square root of both sides. You do r squared and square root both sides, and then that gets you plus or minus 3.
Yeah.
No, yeah, it's square root of 9, which will be plus or minus 3. Yeah.
That one's solved there.
Whew. Are we all good then on this one?
Yeah, I have to go in a few minutes. I have to start getting ready for work.
So what do you think we should do about this horse issue?
Honestly, I
1, 5,
I feel bad because of how little I care about the horses. Like I should care more, but it's given me too much of a headache at this point for me to worry about it.
25 points.
Not helping me enough to make me want to help it.
And we want 39.76. 76. That's our answers. I think we would have gotten that. I can see how you would get these angles.
How?
After you got this, because you could use the formula,
Oh, right.
this formula. But the question is, you need the x and y to get r in the first place. So that's what's confusing me. Or if we had this angle, we could take it and do this. We could do the r cosine, do that backwards to get. I don't know. So this makes sense to me. Once you get the magnitude, that makes perfect sense to me to get those. The question is, how do you get that length first? And I think you get that length by, I don't know, because side angle side is what we have to work with.
And you can't use the Pythagorean theorem to get it.
Because this is not drawn to scale. This is not a right triangle.
Right.
So yes, that's my big question, I guess. How do you get the 425.1 pounds in the first place? Anybody have any ideas?
I have no ideas on this one. I just barely figured out the bottom ones.
Can you use log cosines for this at all? My goodness.
I don't know.
So to find R, you need X and Y. What would be X and Y in this case?
200 and 300 maybe?
That's what I was thinking, maybe. We'll try it. R equals the square root of 300 squared plus 200.
And that's 360.
What?
The square root of 300 squared plus 200 squared is 360.
Well, that's not the answer then. Crap. Something. What on earth do they want from us? Maybe it's 65 and 115.
Maybe the X and Y coordinates are the degrees.
Yeah, that's what I said. Maybe on a limb.
But I don't know how they got 115. It wasn't in the problem, right?
No, that's how we got 150. We got 115.
And she got it too, so we had to get it.
How did we get it?
Because the angle of a parallelogram adds up to 360, and we knew that two of them were 65, so we just had to find the other two. And they're the same, so you could just divide the answer by 2 and you'd have the answer, which is 115.
Alrighty.
Yeah, the angle doesn't work either. It's 132.09, so that's not going to work either. What does this woman want?
Maybe we can email her and ask her to send us a picture of it, of how she would do it. That way we're still learning how to do it, but we're not just fumbling around.
Perhaps.
I mean, if I was a teacher and somebody was like desperately asking me for help, I'd probably, I don't know. I could be wrong though.
Too big. Maybe it's 200. No. Yeah, I think we're going to have to call it a day here. I'll email her and hopefully she can explain it to me, and then I can explain it to you guys by the next one. But I think, honestly, how sad is this? Even though I didn't even go live, we still have like almost the amount of time we need to have a full thing.
So I Googled how to find the resultant vector, and this person says the instructor has a master's degree in engineering. and is currently teaching middle school and high school physics. And she tries to explain vectors. But all these vectors have to do with right angles, and I don't need a right angle.
Well, maybe we have the triangle. Well, no, because we have it as a parallelogram. I was going to say, what if we just did a direct right-angled triangle from the two horses? That wouldn't work. What? Right there. Williams and all.
Oh wait, I got it. Let me screenshot this real quick.
Can I start putting on or no?
Yeah, go ahead.
But I don't want to make cold.
Yeah, cool. I understand. Yeah. Are you guys there?
Yeah.
Are you seeing this?
But what's it mean?
So we did exactly what they did. We found the opposite angles. We have all of everything right there. So we need to find the resultant vector, which is the horizontal that goes through everything. So then we use the law of cosines, apparently. Oh, I don't want to click on that. So what the heck? Gotta click on all these things again. Are you kidding me? So we use the law of cosines. And the law of cosines is minus 2 Okay, so let me try with this, and I can tell you guys how we get that number. Are you ready? Chris, you still there? Okay, guess not.
I think somebody said their internet keeps cutting out. I don't know if that was Chris or Taylor.
Yeah, I don't either. So what are our angles? We have 200 and 300.
Those are the sides. Our angles are 65 and 115.
Right. And then we have minus 2 cosine of 115. I got it, 425.1. I just got it. Taylor, so that was Taylor's connection.
Well, then what in the world did you do?
I did this. So, okay. Can you see it at the bottom of the page?
Yeah, the x squared plus that one.
Yeah,
Yeah.
and so plug in our own thing. So we have x squared equals 300 squared plus 200 squared minus 2 times 300 times 200 times cosine of 115.
Gotcha. And that'll get you that answer.
That'll get you a really big number, which is like 880,714. And then you take the square root of that.
Yeah.
And that gives you 25.
So that gives you the magnitude, right?
Yes.
And then how did they find the angles? Because I would have just figured out. Well, I guess after you found that side,
Now we have,
you'd be able to
now we have all three sides and we can figure it out.
figure out all the angles.
Yeah.
That makes sense.
All right, I'm done. I'm peacing out. I'm dropping the mic on that one.
You figured it out. I'm proud of you. We'll call it a day.
All right. Chris, did you see that? We can't hear you.
Not if you can say yes. Just kidding.
Yeah. Oh, yeah. That was weird.
Did you see that?
Yeah, I put it into the document.
Oh, you did?
Yep.
Did you get the same answer?
Yep.
Sweet. All right. Well, on that,
I think we had to do the law of cosines like at the very beginning, so I'm glad we figured that one out.
yeah, on that note, my wife is making French toast.
I thought to do that from the beginning. I really want to do that from the beginning. I just didn't know how to apply it.
It'd just be too easy.
Stupid
Yeah,
parents.
I'm glad I found that page though, because that was super helpful.
Yeah, it was.
But finding that an hour ago would have been helpful too.
Yeah.
Well, the thing, like, I typed in so many websites just trying to find anything on it, and I couldn't find anything. So,
Freaking
proud of you.
Well, on that note, I gotta go. Now that we figured that out, I can. I'm not gonna lose sleep over this anymore.
2 hours
Enjoy the
later.
French toast.
All right, guys. I'll see you on Thursday.
See ya.
See ya.